Okay, this video is hopefully going to address some of the issues with the problems at hand here, okay? The first section is going to be pertaining to this figure. Point G is the intersection between two lines, okay? Point C is also the intersection between two lines. Are the 3 points collinear? Question that's being asked, okay, with what we have here, okay? Any two points will always be collinear, okay? But 3 points may or may not be. So E, C, and G are on the same line. They are collinear, okay? Uh, B, F, and A are not on the same line, so they are not collinear, okay? That's simply all we need between collinear on a line. Collinear on one line, okay? So any 2 points will always be collinear, okay? 3 points may or may not be collinear. If the 3 points are not collinear, they are coplanar. So we say here, B, D, and E. B, D, and E are not on the same line, so they are non-collinear, but they are in the same plane, so they are coplanar, okay? So they are coplanar. These ask you to name line M, okay, which is right here, in 3 different ways. Line M is a line that contains can be named in any way that contains any 2 points on that line. So for number 9, line M might be line AG. That communicates that line, and there's the line symbol that we use. We could say it's CE also. That communicates the same thing. All right, next section. This box. Think of this box as 3-dimensional. Problem is, we're trying to interpret this on a 2-dimensional surface. Best way to think of this box is the room that you're in right now. And these points are the corners of the room, okay? The floor would be the plane that's defined. Again, a plane is defined with 3 letters, not on the same line. So question 11, it says, what is the name of the bottom? Well, I could say DAB, and that would imply it's the bottom plane, the bottom down here, DAB. I could also say DABC, DCBA. Anything that names, we only need 3 points to name that, okay? The right side, number 16, okay, I'm looking over here. GCBF, GCBH. GCBH is the right side, okay? The figures at the right. Find the name of the intersection where the intersection of each pair of planes. Now, again, think of this box as the room you're in, okay? Think of the edge here where one wall meets the floor, okay? The edge where one wall meets the floor. What you have is any 2 planes, okay, if they intersect, will intersect at a line. Any 2 planes will intersect if they intersect at a line. Number 17 says QRS. QRS is the plane which is the floor, okay? RSW is the plane which is the right wall. They intersect at line RS. So line RS would serve as the intersection for that. Sorry about that. For those 2 planes, RS is the line. Okay, and it's also, you can almost see that because it's the same 2 letters they have in common there. Now that may or may not be the case. Certainly, if the planes have those 2 letters in common, that's the line where they intersect. If they don't, you better check it. Just outline it and check it for yourself. Name 2 planes that intersect at the given line. Well, again, here's the kind of reverse question from that guy. Okay, XT is the dotted line back here. XT is the dotted line back here. Saying what 2 planes intersect at XT? What 2 planes intersect at XT? That's number 23. Well, we have QTX for 1, QTX for 1, and what? The back, which is XTS, and XTX. Now we can use the name, we can name a plane with those 3 letters, and we can tell somebody it's a plane by using the little parallelogram symbol there. So that tells us we're looking at that plane, okay? The next grouping, which I don't even have any questions relevant to that, so we're not even going to worry about that grouping, okay? Let's see, 35 through 37. In a given, is the given point coplanar with the other 3 points, okay? That, again, pertains to, that's going to pertain to the figure up here, okay? The figure up here. So we look at number 37. Point W with XVR, okay? So you got to trace it out. XVR is actually, XVR is a plane that's going to slice this thing diagonal. XVR is going to be the plane that slices this diagonally like this, okay? Now, is that, is the point W on that plane? It is not, okay? So point, for number 37, W is not coplanar with XVR. So if it's not coplanar, it is non-coplanar, okay? It is said to be non-coplanar. So non-coplanar. Okay, let's come down to the exercises referencing what this picture depicts. This picture depicts two intersecting planes. The yellow plane, which could be named for any 3 points not on the same line. So the yellow plane could be named like SYZ, could be named SYC. Okay, that would name the yellow plane. We can see that the pink plane is intersecting it along the line right there at XY. Okay, it is along the line there at XY. All right, so that is the point where they intersect. All right, I'm sorry, I gotta get my inking tool back here. Okay, so the question here for number 43, let's say, is are the points S, V, and C, S, V, C, and Y all on the same plane? Okay, so remember, okay, if we can find a line that goes through 3 of them and the 4th one is not on that, then it's in the plane, okay? So S, V, Y, and C, okay? S, V, and Y are all on the pink plane. C is down here, so they are non-coplanar. They are non-coplanar in number 43. Non-coplanar. All right. Okay, here we go down here to the next section on the front page. If possible, draw a figure to fit the description. 4 points that are collinear. Yeah. Okay, you got a line. You got 1, 2, 3, 4 points on it, right? That's 4 points that are collinear. 3 points, number 51, 3 points that are non-coplanar. I can't do that. I cannot draw that because drawing is on a plane, on a flat surface. If I wanted to represent that, then you have to use your imagination here. I got 1, 2, 3, and I got a 4th point that's off the screen that you're looking at. Then they would be non-coplanar, but I can't draw it, okay? All right, plotting points. I hope we all know how to plot points. Are the points that you plot collinear? Okay, well, one way to do it is to simply plot them out and see if they can all be drawn, if you can draw a straight line through them. All right? Some ways, you don't even have to do that. You can just look, like 52, 0, 0, 0, 2, and 0, 4. There you go. They're all on the y-axis. We knew they were all on the y-axis because they all had the same x-coordinate. So if they're all having the same x-coordinate, then they're going to be a vertical line, and certainly they're going to be collinear. If they all have the same y-coordinate, here you go, they're all going to be collinear. 0, 0, or even look at the y-coordinate the same here, number 58. 2, negative 2, 2, negative 2, that's down here. Okay, negative 2, that's over here, and 3, negative 2, that's over here. Well, since they all had the same y coordinate, then they were collinear, okay, all along there, horizontal line, okay? So if they have the same y coordinate, they're collinear. If they have the same x coordinate, they're collinear. If they don't, then the best bet is to plot them and see whether they are collinear or not, okay? Sometimes, always, or never. Intersecting lines are coplanar. Any two lines that intersect can always be contained on one plane, okay? Any two lines that intersect can always be on one plane. So here's an example, and that's always the case. So number 60 is always. 3 points are collinear? No, sometimes. Okay, we're back. We had a little disruption there. Okay, we're almost done. We want to get through this, and hopefully you're good with this, okay? The last grouping, 66, okay? How many planes contain each line and a point? How many planes contain each line and a point? Here's the line containing EF, okay? We take the line containing EF, all right? We take the line containing EF, and we look at a point G. It's not on there, so it's in the plane of the base of this figure. So you look through that, you're going to find that to be the same for every one of them. So we say for any line and a point not on the line, there is one plane containing them. Which contains them. Sorry about that. Okay, so that's that. Okay, hopefully that helped out, and you got a better understanding of it. Okay.